High-voltage power lines are so dangerous that you can't even get close to them. So why aren't they insulated? What's even stranger, between the power line and the tower, there's only a string of discs. How does that actually hold back the high voltage? Here's the secret. Once the conductor is carried high up into the air around it, plus a safe enough distance, forms the insulation system. If you wrapped hundreds of kilometers of lines in a thick layer of insulation, the weight and the cost would go way up, and the heat from the conductor would become much harder to release. But the trouble starts the moment the line reaches the tower. The tower is made of metal, and it's usually connected to the ground. If the conductor touched the tower directly, the current would get a clear path down to the earth. So engineers had to put something between them, a device that can hold the conductor up, but won't easily let current pass through. That's the electrical insulator. It's usually made of ceramic or glass. The material itself hardly lets current through, and it also has to support the weight and the pull of the conductor. But if you make the insulator a smooth ceramic post, a new problem shows up. There's a very strong electric field between the high-voltage conductor and the tower. If the voltage is high enough, the air in between can break down, and an arc jumps straight from the conductor to the tower. When it rains, if water drops form a complete wet path along the surface of the insulator, the current can creep along the wet surface. When the voltage climbs even higher, one insulator alone can no longer resist flashover. So engineers join several disc insulators end to make an insulator string. The insulation builds up step by step in space. The conductor hangs at the bottom, and the tower holds it at the top. The discs in between keep them apart. Every extra disc pushes the conductor and the tower even further from each other. From the end connected to the conductor, slowly toward the end connected to the tower. This discharge along the surface is called a flashover. That's why insulators have rings of sheds. They look like plates, or like layer upon layer of eaves, and the sheds curve downward, just like eaves, covering the inner surface underneath. When it rains,